There is a city of 5 million people sitting in the middle of one of the hottest deserts on Earth. No river runs through it, no natural lake feeds it, no mountain snowpack is close enough to save it. And yet Phoenix exists, grows, and shows no signs of stopping. Here is exactly how that happened. At number 10, we have something that was already ancient before America was even a country. Beneath the streets of modern Phoenix, there is a ghost grid of canals, not built by settlers, not built by engineers with blueprints and machines, built by people who had neither. The Hohokam civilization was farming the Sonoran Desert starting around the 1st century CE. While Rome was building its roads, these people were building something just as ambitious in the Arizona heat, a water delivery system so large it would not be fully mapped for another 1,000 years. They moved earth by hand. No metal tools, no draft animals for heavy excavation, just human labor, sustained over generations, carving more than 500 miles of canals across the Salt River Valley. Some of those channels stretched 20 miles from the river all the way to the fields. At its peak, this system was feeding a population of up to 80,000 people in a desert that gets less than 8 inches of rain per year. That is not farming in a difficult environment. That is completely rewriting what that environment is capable of producing. Then around 1450 CE, the Hohokam were gone. The reasons are still debated, but the canals remained, pressed into the desert floor like a fingerprint left in dry clay. Faint, intact, waiting. For 400 years, nobody who could use them knew they were there. In 1868, a man named Jack Swilling rode through the Salt River Valley and looked at the ground differently than everyone else had. He saw the old routes. He cleared them. He sent water flowing through channels that had been silent for 4 centuries. Crops appeared in the desert within months. The settlement that formed around Swilling's work was named Phoenix because it rose from the remains of a civilization that came before. Today, portions of those ancient roots still underpin the modern Salt River Project canal system. Number 10 was not just infrastructure, it was the original blueprint for everything. Coming in at number 9 is the system that turned that ancient blueprint into a modern water empire. By the late 1800s, farmers in the Salt River Valley had a brutal problem. The river flooded and destroyed crops. Then it ran dry and left fields cracked and dead. There was no middle ground, no storage, no control, just the desert doing whatever it wanted and farmers trying to survive it. The only solution was to stop the river from behaving like a river. Someone had to dam it, and nobody had anywhere near enough money to do it. So the farmers did something that had never been tried at that scale before. They pledged their own land as collateral to fund the project themselves. The Salt River Valley Water Users Association was formed, and its members essentially bet their farms on a dam that did not yet exist. Construction on Theodore Roosevelt Dam began on August 24, 1903. The site sat 76 miles northeast of Phoenix in a remote canyon that barely had a road leading to it. Workers had to carve the access route before they could even begin breaking ground on the dam itself. When Roosevelt Dam was completed in 1911, it was the first major structure finished by the newly formed U.S. Bureau of Reclamation. It stood 280 feet high, built from rubble masonry, and it held back more water than the entire valley had ever controlled at one time in its history. It was also the first Bureau of Reclamation project to include a hydroelectric power plant. For the first time, electric light reached Arizona homes. The dam was not just storing water, it was generating the power that would make every engineering project that came after it physically possible. The Salt River Project grew from that foundation into something enormous. 6 storage dams, nearly 1,259 miles of canals and laterals, 5 hydroelectric plants, a 240,000 acre service area, delivering more than 1 million acre-feet of water every year. All of it tracing back to a bet farmers made with their land. At number 8 is a dam most people mentally hand to Nevada. But Hoover Dam sits directly on the border between Arizona and Nevada, and what it unlocked for Arizona specifically is a story most people have never been told. It starts with a river that nobody could predict. Before Hoover Dam, the Colorado River was dangerous. It flooded farming communities without warning. Then it ran nearly dry and left the same communities with nothing. The entire Southwest was at the mercy of a river that followed no schedule anyone could plan a civilization around. Construction ran from 1931 to 1936, during the Great Depression, when the federal government needed a project large enough to put thousands of men to work. The dam rises 726 feet and used over 3.25 million cubic yards of concrete. The scale of it was unlike anything built before in America. Engineers faced a problem nobody had fully solved at that size before. Concrete generates enormous heat as it cures. At that volume, left alone, it would have taken roughly 100 years to cool completely. Their fix was to embed more than 582 miles of cooling pipes directly inside the structure. The result was Lake Mead, which at the time of completion was the largest artificial reservoir in the world. The dam's 17 turbines generate approximately 4.5 billion kilowatt hours of electricity per year, serving millions of people across Arizona, Nevada, and California, with power that the desert could not otherwise produce. For Arizona specifically, Hoover Dam did something beyond flood control and electricity. It proved that the Colorado River could be tamed, stored, and allocated. That proof created the legal and political pressure that eventually forced a formal agreement over who actually owned the river's water. Without Hoover Dam establishing that the Colorado could be controlled, the framework that gave Arizona its share of the river would likely never have been built. And without that share, the project at number 6 on this list would never have had a single drop of water to move. At number 7 is a dam that almost started a war between two American states. Parker Dam sits about 155 miles downstream from Hoover on the Colorado River. Most people have never heard of it, but without it, the entire water system feeding Arizona cities simply does not exist. Completed in 1938, Parker Dam created Lake Havasu, which became the intake point for the Central Arizona Project. Every drop of Colorado River water that travels 336 miles across the state to reach Phoenix and Tucson starts its journey right here. Parker Dam is the tap. Without it, the pipe is empty. The dam holds a record that surprises people when they hear it. It is often described as the deepest dam in the world, not because of how tall it stands above the riverbed, but because of how far it goes below it. The silt at that section of the Colorado was so deep that engineers had to excavate far into the riverbed before they could set the foundation. Roughly 2/3 of the dam's total structural height is buried underground. What you see standing above the waterline is only a fraction of what was actually built. Most of the engineering is invisible, locked beneath the riverbed, holding everything above it in place. Arizona's relationship with this dam did not start peacefully. When California began construction in 1934, Arizona's governor decided the state was not going to accept it. He declared martial law and deployed infantry troops to the construction site to monitor what was happening across the river. For a brief stretch of time, Arizona had what newspapers mockingly called the Arizona Navy, a small fleet of boats manned by state militia watching California build a dam on a shared river. The confrontation never escalated into actual conflict, but the political tension around it lasted for years afterward. Despite all of that friction, Parker Dam became indispensable to Arizona, in a way the state's governor could not have anticipated in 1934. The same dam Arizona tried to block is now the starting point of the water lifeline, keeping its largest cities alive. Number 7 is where the water begins. At number 6 is the largest and most expensive aqueduct system ever built in the United States. The Central Arizona Project stretches 336 miles from Lake Havasu all the way to south of Tucson, delivering water to the 3 most populated counties in the state. But the engineering behind it is the part that genuinely does not make sense until you see the numbers. The cap moves water uphill. Not a small incline. Not a gentle grade. The system lifts water a total of more than 2,900 feet in elevation over its entire length. Moving that much water that far against gravity requires a solution that sounds more like science fiction than civil engineering. The answer was 14 pumping plants distributed along the route. At the very start of the system, the Mark Wilmer pumping plant uses 6 pumps, each rated at 66,000 horsepower, to lift water over 800 vertical feet in a single step. That is one pump doing the work of thousands of engines simultaneously. After that first lift, the water disappears. It enters a 7-mile tunnel bored directly through Buckskin Mountain, emerging on the other side into an open concrete-lined canal that stretches nearly 174 miles. 7 major inverted siphons and 3 additional tunnels carry it the rest of the way across the state. Construction began in 1973 and was declared substantially complete in 1993. The total cost came in at more than $4.4 billion, making it the most expensive water infrastructure project in American history at the time. Every mile of it had to be carved through desert terrain that offered no easy path. The cap also includes Lake Pleasant, formed by Navajo Dam, which serves as the project's primary storage reservoir along the route. Water can be banked there when demand is low and released when cities need it most. It gave the system flexibility that a single straight canal could never provide. By the mid-20th century, Arizona's underground aquifers were being pumped out 500 times faster than rainfall could refill them. The cap arrived at the last possible moment and provided a renewable surface water supply that prevented the complete collapse of the groundwater system beneath Arizona's cities. Number 6 bought the state time it desperately needed. At number 5 is the facility that physically powered everything at number 6. Moving hundreds of millions of gallons of water uphill across hundreds of miles of desert requires electricity on a scale that most power grids struggle to imagine. For decades, one plant carried almost all of that load alone. The Navajo Generating Station was a coal-fired power plant located on the Navajo Nation near Page, Arizona. At a rated capacity of 2.25 gigawatts, it was the largest coal-fired power plant in the western United States during its operating years. It was built for one specific reason. The U.S. Bureau of Reclamation needed a dedicated large-scale power source to run the cap's pumping plants. Two proposed hydroelectric dams on the Colorado River near the Grand Canyon were considered and then rejected due to environmental opposition. The coal plant at Page was the alternative that actually got built. What made this arrangement unusual was the specificity of the dependency. The Navajo Generating Station was not a general-purpose power plant that happened to supply the cap. It was designed with the cap's energy needs as the primary objective. The pumps and the plant were engineered as a single system. That system moved approximately 1.5 million acre-feet of Colorado River water annually to central and southern Arizona every year. For nearly half a century, the electricity generated at Page traveled to pumping stations across the state and lifted an almost incomprehensible volume of water to places it had no natural reason to reach. The plant operated from the 1970s until November 2019, when it ceased commercial generation. After nearly 50 years of continuous operation, the KP transitioned to sourcing power from other providers. The infrastructure remained, the water kept moving, but the plant that had driven the whole system went silent. For almost half a century, the Navajo Generating Station was the mechanical reason Phoenix had running water. Number 5 never appeared on a city skyline, or drew tourists, or made it onto a postcard. But without it, the canal at number 6 was just a very expensive concrete ditch going nowhere. At number 4 is the engineering challenge nobody talks about because it has no dramatic finale. Before any dam gets built in a remote canyon, before any canal gets carved through mountain terrain, someone has to figure out how to get there. And in early 20th century Arizona, that was its own crisis. The construction of Theodore Roosevelt Dam in the early 1900s required a road through some of the most rugged terrain in central Arizona. That road became State Route 88, known today as the Apache Trail. Originally built in 1904 as a wagon road, it wound through cliffs and canyon edges that barely had room for a cart. Workers had to carve that path before a single piece of dam equipment could move through it. The road came first, the dam came second. Every major construction project in Arizona during that era followed the same logic. You could not build anything until you could physically reach the site. By 1916, Arizona had more than 12,000 registered automobiles and not a single mile of paved road in the entire state. The vehicles existed, the routes did not. Connecting Arizona's mining camps, construction sites, and isolated communities meant building a road system essentially from scratch across terrain that resisted every attempt. The decades that followed brought systematic paving across the state, eventually connecting Arizona to the national interstate system. Interstate 10, running through Phoenix and Tucson and linking Arizona to both California and Texas, became one of the most critical commercial corridors in the American Southwest. Every major engineering project on this list required physical access to a remote location. Materials had to arrive, workers had to live, equipment had to move in and eventually out. None of the dams, canals, or power plants could have been constructed without a road network capable of supporting their weight and volume. Number 4 is not a single structure. It is the condition that made every other structure on this list physically buildable. The roads came first, and without them, everything else on this countdown stays a blueprint sitting in a drawer somewhere in Washington. That is why it earns its place here. At number 3 is a project that solved a specific injustice, while also opening up a large section of central Arizona to sustained agriculture. The San Carlos Irrigation Project served a part of the state that neither Roosevelt Dam nor the cap was built to reach. It started with a river being stolen. The Gila River had sustained the Pima people for generations. Their agricultural civilization along the river was functional and established long before American settlers arrived in the region. Then upstream development began diverting the Gila River's water away from the reservation, and the fields the Pima had farmed for centuries began to fail. By the early 20th century, the situation had become severe enough that the federal government was pressured to act. Congress authorized the San Carlos Act in 1924, creating a joint federal project to deliver Gila River water to both tribal agricultural lands and non-Indian farmlands in the Florence-Casa Grande Valley. The centerpiece of the project was Coolidge Dam, completed in 1930 on the Gila River. The dam created San Carlos Lake and gave the project the storage capacity it needed to regulate water delivery across a large and geographically spread out service area in central Arizona. The project ultimately encompassed 100,000 acres of irrigable land, split evenly between tribal and non-tribal users. That split was written into the authorization from the beginning. The federal government was not just building irrigation infrastructure, it was codifying a legal water right for people whose water had already been taken once. Beyond the dam, the San Carlos Irrigation Project included storage reservoirs, diversion dams, canals, distribution systems, irrigation wells, and pumping plants spread across the Gila River corridor. It was less a single structure and more a complete agricultural water system built across an entire river valley. Number 3 does not have the scale of the cap or the fame of Hoover Dam, but it delivered water to a part of Arizona that the bigger projects were not designed to serve, and it did so while trying to correct something that had already gone badly wrong. That combination earns it this spot. At number 2 is a power plant that should not exist where it does. Every nuclear facility ever built uses enormous volumes of water to cool its reactors. Rivers, lakes, coastlines. Power plants get built next to water. That rule applies everywhere in the world except one place about 45 miles west of Phoenix. The Palo Verde Nuclear Generating Station near Tonopah, Arizona is the largest nuclear power plant in the United States by electricity generation. It consists of 3 pressurized water reactors, each capable of producing up to 1.4 gigawatts of power after upgrades. Together, they generate approximately 32 million megawatt hours of electricity per year. That output serves around 4 million people across Arizona, Southern California, New Mexico, and Nevada. Roughly 35% of all electricity produced in Arizona comes from this single facility. By any measure, it is the most productive power plant the state has ever built. And it sits in the middle of dry desert. The cooling system is what makes Palo Verde unlike anything else on Earth. Nuclear plants produce enormous heat that has to be removed constantly. The standard solution is to draw water from a nearby body of water and run it through the cooling process. Palo Verde had no nearby body of water to draw from, so the engineers used something nobody had used for a nuclear plant before: treated municipal wastewater. Sewage effluent piped in from the metropolitan Phoenix communities surrounding the plant, processed, and then used to cool the reactors. The plant evaporates up to 26 billion gallons of reclaimed water per year doing this. Construction began in 1976. The plant became fully operational in 1988 at a cost of approximately $5.9 billion. It was one of the most expensive construction projects in Arizona's history, and its economic impact on the state since opening has been estimated at $1.8 billion annually. Without Palo Verde, the electricity demands of Arizona's growing cities, data centers, and water infrastructure would be significantly harder to meet. The cap pumps need power. The cities need air conditioning. The data centers need continuous electricity. Number 2 is the reason the grid holds together when Arizona summer hits full force. But number 1 is where everything changes. Because the most consequential engineering achievement in Arizona's history was not built with concrete. It was not drilled through a mountain. It was not poured into a dam foundation at the edge of a canyon. It happened in courtrooms and across conference tables. The Colorado River Compact of 1922 was brokered by then Secretary of Commerce Herbert Hoover. 7 western states sat down and divided the river's flow between them, splitting into an upper basin and a lower basin. Without that agreement, every dam, canal, and pumping plant built on the Colorado would have been a legal battleground with no resolution. Arizona refused to ratify the compact until 1944. For more than 2 decades, the state fought California over its share of the river in what became one of the longest and most expensive interstate water disputes in American legal history. The argument was existential. Whoever won the water won the right to build a future in the desert. The dispute went to the U.S. Supreme Court. In 1963, Arizona finally won a ruling establishing its right to 2.8 million acre-feet of Colorado River water per year. That number is not a detail. It is the legal foundation on which every physical structure on this entire list was built or justified. Without that ruling, there was no basis to construct the 336-mile canal. No authority to operate the pumping plants. No water to send through the system that took 20 years and $4.4 billion to build. The Central Arizona Project did not become viable because of engineering. It became viable because of that courtroom decision. Every skyscraper in Phoenix traces back to that ruling. Every irrigated field in Pinal County, every glass of water in Tucson, every data center, every suburb, every agricultural operation that makes Arizona one of the most productive farming states in a region that should not be able to farm at all. The dams are impressive. The canals are remarkable. The power plants are extraordinary. But the legal framework that told the world Arizona had the right to the water is the reason any of it got built in the first place. Number 1 was never made of steel. It was made of law.